Find the angles of the triangle if angle A, which is x, is 30 degrees greater than angle B, which is 5y. So A is bigger than B. So what this means is that A is not equal to B. Therefore, x is not equal to 5y. The value of x here is not equal to 5y. X is greater than 5y. The value of x is 30 degrees greater than 5y. So value of x is 30 degrees plus 5y. So we can simply write that as x is equal to 30 degrees plus 5y. We can rearrange this equation so that we'll have variables y and x on one side. So we'll take 5y across. 5y is plus 5y here. When it goes across, the equal to sign becomes minus 5y. So we'll have x minus 5y to be equal to 30 degrees. You see this equation now, it has two variables. If we had one variable, we can easily solve our linear equation, but we'll have two variables. So we'll try and bring in another. Let's see if we can get another equation. In solving two variables like this, you may need more than one equation to actually solve an equation that carries more than one variable. So let's look at the question again. If you look at this triangle, the sum of all the angles of a triangle is usually equal to 180 degrees. So let's sum this triangle. Let's sum all the angles in this triangle. If we say x plus x, x here plus x plus 5y, it should give us 180 degrees. Because the sum of angles in the triangle is 180. So x plus s will give you here 2x plus 5y is equal to 180 degrees. You cannot add x to y. Just you cannot subtract x from y here. So you leave the equation the way it is. You call this one equation 1. You call this one equation 2. We're going to solve these two equations at the same time. And another word for same time is simultaneously. Simultaneously. So they are simultaneous equations. We're going to solve them simultaneously together. Our equations are, if we write them out, we'll have x minus 5y to be equal to 30, equation 1, and 2x plus 5y is equal to 180 degrees, equation 2. In solving simultaneous equation, at this stage, you can actually use two methods in solving simultaneous equation. You can use the elimination method by subtracting equation 2 from equation 1, or subtracting one equation from the other one, that is eliminating, or use the substitution method. We are going to use the elimination method. It seems to be faster for me. Now, supposing we had x here and x here, we would have said x minus x. By using the elimination method, we'll have 0. We'll not be left with only y. But the fortunate thing is that we'll have 2x here, not x. So if we say x minus 2x, it will not give us 0. If we say 5y minus 5y here, it also will not give us 0. So what we'll do is, we're going to try as much as possible to introduce 2 here, so that when we say 2x minus 2x, we'll have 0. So but if you're introducing 2 to this side of the equation, we must do the same thing for all of them, because this is an equation. It's like a seesaw. What you have here must balance what you have here. If you add anything here, you must add the same thing to this other side. Otherwise, the equilibrium position of this seesaw will change. You do that tilt this way or tilt this way. So we're going to multiply this equation by this side by 2 of the equation. We multiply this side of the equation by 2 also. So we're going to have 2 bracket x minus 5y. Talking about equation 1 now, bracket close. So we go to 2 times 30. And that will give us 2 times x will give us 2x. 2 times minus 5 will give us minus 10y to be equal to 60. We'll call this one equation 3, because the equation has changed. Why this equation here, we'll still bring it here. 2x plus 5y to be equal to 180 degrees is still our equation 2. So now we'll subtract this equation from the other equation using what we call the elimination method. elimination method of solving simultaneous equation. Just like in your normal subtraction, when you have 1 over 2, 12 minus 32, want to subtract, you rule a line. Similarly, you also rule a line when subtracting simultaneous equation. So we're going to say 2x minus 2x. Here, it's not just 2x, there's a plus in front of 2x, and there's a plus in front of 2x here. So we'll have plus 2x, which is this, minus plus 2x. You subtract that, you have 2x minus plus will give you minus. 2x minus 2x will give you 0. So you have 0 here. The next one, minus 10y minus plus 5y. Minus 10y plus minus times plus will give you minus. Minus 10y minus 5y will give you minus 15y to be equal to 60 plus 60 here minus plus 180. Minus plus will give you minus. You have 60 minus 180, that gives you minus 120. So you have minus 15y to be equal to minus 120. If you divide both sides by 15, so that you can remove 15 from here, you have minus 15y divided by 15. And, sorry, divide both sides by minus 15. Minus 15y divided by minus 15 is equal to minus 120 divided by minus 15. I'm using minus for both sides because so that I can cancel out minus sides, come out to both sides. 15 cancel 15, minus cancel minus. 15 cancel 120, minus cancel minus. On this side, you'll be left with just y to be equal to, here you have 8 as your value for y. So y is equal to 8. So let's look for x. You recall from this equation that x, one of the equation, x is equal to 30 degrees plus 5y. Let's use that to look for x. From our introduction, we have x to be equal to 30 degrees plus 5y. So if you substitute the value of y to replace y here, we'll have x to be equal to 30 degrees plus 5 brackets 8. And that gives you 30 plus 5 times 8 will give you 40. So x is 70 degrees. If you recall from the triangle here, we had x and 5y as the angles of the triangle. So here is 70 degrees. Here is also 70 degrees. They are both x. So to find 5y, y is 8. So if you substitute 8 in place of y, you have 5 times 8, which is 40. So y is 40 degrees. The angles are 70 degrees, and 40 degrees.